Okay, this is the last lesson of our unit here, and then like I've been telling you, tomorrow we'll start with reviews, and Friday we'll do a test. This lesson, it's titled up there, Modeling with Exponential Functions. All this is going to do, basically, is we're going to learn, if we're given a couple of points off of an exponential growth or an exponential decay graph, we're going to learn how to write the equation out of those points. Okay, the main importance of this whole unit is what we did yesterday. Learning to use all the stuff that we've covered to solve the different equations. That's the main gist. But we do need to know how to do this today as well. So to start off with, I've got a couple of tables that we're going to be presented. And this question always comes up on our test on this unit. If you're given a table, being able to figure out what type of model it is based on the table. So I'm going to give us two different ones. Here I've got an X and a Y table that the X's go from -2 to 4, counting by ones. Okay. Oops. And then my Y's go 0.5. No, 0.1, 0.5, 1, 2, 4, 8, 6, 7, 32. Okay, there's table 1 we'll talk about. I'll go ahead and write the other one up here while I'm in the business of writing tables. X's on table 2 go -2, 0, they count by 2's. 6, 8, 10. And then my Y's on this one, 2, 0, 2, 8. No, 18.
Is that 0.5?
Uh-huh. Okay, so the directions for both of these tables say describe the type of function represented by the data. So types of functions that we know that we've covered so far that this could be. Start off with some basic, easy, schmeezy linear. We did linear things. If we are a linear function, y equals mx plus b, you have a slope, so it's going up by a constant or going down by a constant. It's being added or subtracted by the same thing every time. Your y's are consistently rising too every time. You've got a constant slope on that if we're linear. Then we spend a whole heck of a lot of time on quadratics. The unit we're on now is exponential and logarithmic. So that's the answer, the type of answer you're going to have to what do those tables represent. So first thing you always check for in this table is like you see what the y's are doing, because you notice the x's are consistent. The x's are going up 1 on the first table, right? -2, -1, 0, 1, 2, 3, 4. They're going up 1 every time. So we look down to our y's and see if there's something consistent happening there. So I would look here on my y's and I would say, well, from 1/2 to 1, that goes up 1/2. But from 1 to 2, that goes up 1. From 2 to 4, that goes up 2. So it's not being added the same thing every time. So then I would check for that multiplication that Garrett's all over. He says they're being multiplied by 2 every time. So let's check that. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So it is being multiplied by 2 every time. That in patterns and sequences, if it's being multiplied or divided, that's called a common ratio. So this has a common ratio of 2, is what you would say on that. It's being multiplied by 2 every time. So the answer of our question, which was describe the type of function represented, when you have a common ratio, if it's being multiplied by the same thing like that every time, that is what we're doing now. That will make it exponential. E-X-P-O-N-E-N-T-I-A-L. So if we had that question on a test, and it was being multiplied by the same thing every time, we would say it's an exponential function. Okay? If it's being multiplied by the same thing every time, it's an exponential function. That's important. Some of y'all don't seem to care.
So multiply.
Uh-huh. Look at the second one that we got there. My x's are going up by 2 every time. They have 2, 0, 2, 4, 6, 8, 10, so that's consistent. So let's check out the y's. from 2 to 0 goes down 2, and then 0 to 2 goes back up 2. 2 to 8 goes up 6, so they're not being added by the same thing every time, so it's not linear. Are they being multiplied by the same thing every time?
No.
No, that 0 in there won't let it be, will it? Because anytime you get a 0, 2 times 0 is 0, then everything else would have to be 0. So it can't be multiplied, so it can't be exponential.
Wait.
So, go ahead.
Never mind.
It's not add.
We already said that. It's not linear. It's not exponential. So the next thing to check for would be that quadratic. Now remember a quadratic when we did those parabolas? Quadratic is to the second power. So for this thing to be a quadratic, this is funny to say it this way, but it means the second level has to be consistent. So what that means, y'all follow this. This will be new for a few of you. If I went on my first level here, I would say that one goes down 2. That one goes up 2. That one goes up 6. That one goes up 10. That one goes up 14.
Oh, it's going up by 4.
Is that one up 14? That one goes up 2 minus 2 is 18. Okay, so there's my first level of differences. So quadratic, I said you need to check your second level. So what we're going to do now is that same thing I did there, but I'm going to do on these numbers. So from negative 2 to 2, if I'm counting on the number line, I would go up 4. From 2 to 6, up 4. From 6 to 10, up 4. From 10 to 14, up 4. And from 14 to 18, up 4. So since my second level was the same, that's what makes this function be quadratic. Okay? And every year on the test for this unit, there's a question that's, you got to be able to do that. You got to be able to figure out if it's exponential or quadratic like that. Alright, then the rest of the stuff, all we've got to look at is what I was telling you earlier. If I give you a couple of points, or if I give you a graph, us being able to write the equation for it. So, everybody done with the tables there, ready to rock it? Alright. Let's say I had 2 points here, 1, 6, and 3, 54. Alright, now, first off, I would think you would be able to realize this is an exponential growth. If you just look at the 2 points I gave you and just visualize what that would look like on a graph. If I go over 1 and up 6, I'm just estimating over 1 up 6, over 3, up 54. So that's going up real high, real fast. So that would be an exponential growth. So remember, those graphs look something like that. So we've got to be able to use those 2 points and get the equation for that curve. Okay? We're going to start with every time. You need some good steps to follow in your notes on this. It's not hard. There's just several steps. We're going to start with every time that basic exponential model. Remember, it's exponential if the variable is an exponent. So y equals ab to the x is our starting spot. Now we've got over here in these 2 points, we've got an x and a y with the 1 and the 6, and we've got an x and a y with the 3 and the 54. So what we got to be able to do is use those x's and y's to figure out what's going to go in the a and the b place. So I'm going to come over here to my 1 and 6. There's an x, there's a y, so I'm going to plug those in for the x and the y on that equation. So I'm going to have 6 equals AB to the first power. Get this, Michaela? You're going to wish you had it. Same thing with the 3 and the 54. That's my x and my y. So I'm going to have 54 equals AB to the third power. So that was step 1. We plugged the x's and the y's, and we made up 2 new equations. Now remember, we're trying to figure out a's and b's. So if I look at what's happening on these 2 new equations that we have in blue, the a's have got less going on. The A is always going to stay A to the first power, isn't it? Because the exponent's on the B. So it would be easier for me to solve one of these equations for A, because they got less going on them. It doesn't matter which one. I always pick the one with the smaller numbers. So I would say, let's take this one right here and get the A all by itself. To get the A all by itself, it's being multiplied by B. How do I undo that? So I'm going to divide both sides by B. B is the same as B to the first. So we end up with an equation that says A equals 6 divided by B. Okay, so now what you've done, if this is what A is, you ought to be able to take that over here and put it in for A, right? Okay, I told you it's a several step process. You're going to be glad you got it in your notes to follow. 54, instead of A, I'm putting what A is, times B cubed. Alright, now you've got to see that 6 over B times B cubed. You've got to see that and be able to simplify that. You've got 6 over B, and then B cubed is the same as B cubed over 1. So if you look at multiplying this, and I'm going to skip some of these steps when I work it on the board, but I want you to see what's happening. If you look at multiplying this will be 6B cubed over B. What happens to those B's?
They
Cancel.
This one does all the way. What is this one?
That one goes to B squared.
Right, because remember your exponent rules. 3 minus 1 makes that 2. So we end up with just 6B squared.
And that equals 54.
And that equals
Yeah, I got
54.
middle school equation.
Now you got it, sir. So we've got 54 equals 6B squared. We're trying to figure out B. So what would we do to get this first step to get the B by itself? Good, ma'am. Divide by 6. So 9, 54 divided by 6 is 9, is equal to B squared. Now I would undo the squared. Lane and Joe said it. How do you undo a squared? Lane and Joe's the only one that said it so far.
Square root of
Square root it, and the square root of B can be positive or negative 3 like Lane and Joe said, but this is the only time where we just are going to take the positive one. Okay? Now, match that up. Remember, our goal here was trying to find A and B. Match that up with over here. Look at this. This will tell me my A now, won't it? Because I can plug a 3 down there for that B. So my A
equals 3.
is, 6 divided by 3 is
2.
2. So we've got an A. We got a B. We're going to go back to the very original right here and plug them in, and you've got your equation. Let me get a new color up here at the top. Y equals A times B to the X.
It's not bad.
There was not any difficult math at all. It just took us several steps to get there. That's what concerns me for some of us. We'll try another one. Try again. this says a store sells trampolines. Y'all listen, because this is how that same type of problem that we just did could be presented to you. A store sells trampolines. The table shows the number Y of trampolines sold during the X year that the store has been open. Write a function that models the data. So this is the exact same type of problem that we did on the previous screen, but on the previous screen, rewind a second, look at this. On the previous screen, I just gave you 2 points, a 1 and a 6 and a 3 and 54, 2 points. Here I gave you 1, 2, 7. So we've got 7 points. How many do we need to do the equations? 2. So this is where you have the freedom to choose any of those 2 points you want.
Okay, so we can do it at either any point we
Uh-huh.
want.
Now, I recommend keeping small, so I would start probably either with the 112 or the 216. Pick one of the smaller ones. And okay, 112, I heard already. And then just don't pick the one right next to it. Skip a couple. So 112 and what other one you want to use?
436.
Okay, 436. 550 would work as well. It doesn't matter. You don't, because y'all know when we look at the graph of this, sometimes those first ones are real close down here. So we want to be able to get one where it's low and then one where it goes up. See, while we're choosing the spread out. Okay, so now we're going to do the exact same thing we did on the previous page. Y equals AB to the X. Y equals AB to the 4. The X. My X was 4.
So, I have a question. On this one, where's the
That's a B. Oh, what are you from?
on top when you set it up? Here, you said this was.
Oh, from, where did I get that from? Can you rewind me? Got it all written down. Yeah, from that point.
Okay.
Write those points down there so you'll know. Alright, after we plugged our Y and our X in on the previous page, the next thing we did was solve one of the problems for A. Now let me tell you, you could solve it for B, but there's more happening because B's got the exponent. It's easier to solve one of them for A. Okay, I would always guide you to solve your smaller one for A. So I would do this one, but if you choose the other way, it's okay. Just be more work for you. So right here where my mouse is, where I'm guiding you, what would I do to get that A all by itself? Divide by B to the first, which is just B. So A would equal 12. Good, Chloe. Good job. Okay. So now all you're going to do is take what A is and go to your other equation and plug it in. Okay, so we'll say 36 equals 12 over B times B to the 4th. So see if we can skip a step here now. 36 equals 12 B to the 3rd. Good, Laney Joe. Everybody okay on that? Just like we did over there by River on the dry erase board a second ago. B to the 4th over B to the 1st is B cubed. Okay, we can solve this for B now. What would I do to undo that time? Good, divide by 12 on both sides.
So B3 equals B to the 3rd.
Okay, so 36 divided by 12 is 3 equals B to the 3rd. No, this one's not going to be friendly for you. Undo the 3rd power by taking the 3rd root. So we do the cube root of 3. And we're going to get an ugly decimal here. Is that what everybody got? Okay, so we'll round that and use the 1.4. Now that's the risk you run into when you pick any points you want. Would everybody necessarily get that same thing for their B? Not necessarily. Remember, you did this same exercise with linear things in Algebra 1. It should be in the same ballpark, but it might not be exact. So we got our B is 1.4, so we're going to take that and use it to figure out our A. So our A is going to equal 12 divided by 1.4. What do you got?
8.57.
So I'm going to say about 8.6 since I did the other one in tenths. I'll keep this one in tenths. So for my final answer, I've got an A, I've got a B. All I got to do is say Y equals my A times my B to the X power. That's your final answer.
That made a lot more sense this time.
Good. Usually it takes a couple. So my book answer had their B was 1.44, so hey, we did pretty good on it. Their A was 8.32. So we're in the ballpark. Let me see what points they used. The 1, the 12, and the 5 and the 50. That's what it looks like.
And if we went to another decimal point, we would still get the same.
We would, it'd be the exact same. So when I rounded my 1.4 off, yeah, that's cool. That's cool. And just checking us out on that. All right. You want to try one by yourself? I think that'd be a good idea.
Sure.
Because this is all that there is for today.
I feel pretty confident about it.
I think you can do it.
But
Are we going to the
I
board?
say that, but then you're gonna throw.
I'm just going to give you a couple points. So that way I can see everybody's the same when I'm helping. All right, so we got a 1-3 and a 2-12. I want you to see if you can write the equation, the exponential growth model that goes through 1-3 and 2-12. I'm going to give you a little bit of time. You can do it. If you want to go to a board, you can. If you want to stay on your notes, you can. Either way works for me. So b squared over b would reduce, because you got a 2 minus a 1, so that would reduce to just b. So your 12 would equal 3b. Just simplify those So this was a b cubed over a b. So 3, a b cubed, and a b to the first. So you just subtract the exponents on division. So 3 minus 1 is b squared.
Wait, that's
B to the first or just b? Yes.
Write it in.
Points Either one. And now divide by 3. Get the deal by 7. Yeah, that would be easier, yeah.
Why are you changing it late?
I got
I got a couple people finishing up, so we'll give you a little bit more time. You did. So now write it into your equation. So just put y equals whatever your A and whatever your B is at. Good job. Did you say your B was? Alright, most everybody I gandered at was pretty good. So one thing that some of y'all are going to forget is how the equation starts off. Soon the mouse turns back on. How the equation starts off in the beginning. Your y equals ab to the x. So make sure you've got that down. Why is it frozen on me suddenly?
It said no more matter.
It's on the last problem, and I'll get to the thing. Okay, so that's what I was saying. Some of y'all are going to even forget that. Most of y'all have written it down, but a few of you still haven't. Y equals AB to the X is where we're going to start. And then go with both of your ordered pair, whether I give it to you, but let them grip them up, whether I give it to you as an ordered pair or a table, pick your two and plug the Y and the X in on that spot. Make sure you plug them in the right place. So 3 is my Y, AB to the first. This one, 12 is my Y, AB to the second. Solve one of your equations for A. My guidance is solve the one with the smaller numbers for A. So to get this one's A all by itself, it's being multiplied by B in the first, which is just B. So I would divide by B. So A is equal to 3 divided by B.
Yeah.
Okay, that's most of the battle there. If you get that right, it's not too difficult to go and plug that in to the other equation. 12 equals 3 over B times B squared. Every question that somebody asked while they were working on their own on that one was about this place. So you've got to, if you need to write this out, if you need to say this is the same as 3B squared over B, so that then you can see your B squared and B, do some reducing there, then write it out that way. Okay, B squared over B reduces to just 3B. So then your last step on that, divide by 3, and you got a B of 4. Okay, then take that. Easiest place to plug it back into is the place where you've already solved for A. You take that, plug it back in here.
I did that right.
Good. 3 over 4, you can leave it that, since that doesn't reduce, you can leave it that way. I saw some 0.75s, you can put 0.75. They're the same, either one works. You've now got an A. You've now got a B. Your final answer comes back from this, plugging it in to the original up here. So we're going to say Y equals 3/4 times 4 to the X. Very good. And you don't multiply those A's and B's together. Anybody know why? But it's that exponent. That exponent happens on the x. So if you're thinking about, like, say, I want to know, because this is an exponential growth curve. This is something that looks like that from left to right that I just drew up there. If I wanted to know when x is 5, and I've already multiplied those together, that would construe that equation, because the 5 only goes to the 4. Okay, so don't multiply them together for your final answer. Okay, so a lot of info in this unit, and the majority of this info is new. It's not like when I told you earlier, so much of the stuff that we've done in here up until now has just been building on previous things. A lot of this log stuff was new for a bunch of us. Tomorrow we're going to work on the study guide, and I'm not going to help you on it at all tomorrow, and you're not going to get to work with a buddy on it at all tomorrow. You're going to pretend like it's a test. What would happen if tomorrow was the test day? Okay? Then the following day we'll clean it up and talk about what we need to talk about and get it knocked out. Test will be on Friday. The project that follows this unit, it's a exponential decay project. So we'll be seeing stuff that looks like that on our exponential. It's going to be about how the value of a new car depreciates. It's tied for first for my favorite project, but it's the most tedious one. There's a lot that goes into it.
Or are we doing it like
It's in, it's in threes, I believe. I'll have to check my rules on it. I think it's in threes because we do 3 cars, but I'll check my rules on it and see. Look it up.
Comedy comes in 3.